Hello, hello. How are some of my favorite people doing? Hopefully well. We're going to be looking at the Chapter 10 quiz today. So what I did is I just copy and pasted the problems out of Moodle onto this worksheet. So I'm going to go through each problem. Now remember, I made the quiz in such a way that the numbers would change, the problems would be the same, the numbers would change for different people. So your numbers might be different, but the process is the same. If you go through this and you're still stuck on how to do something, please email me and I can go back to your quiz and grab the exact question that you did and do it for you, whatever is necessary. So I'm gonna go through this quiz and you can just bop around, obviously, and look at the ones you got wrong. So this could be kind of a longer video, but just look at the ones you need to look at in preparation for the test this week. All right, what is the surface area of a regular triangle pyramid with a base of 12 and a slant height of the pyramid's 30? Okay, so try to draw a picture. Recall that a regular, when it says regular, that means that it's equilateral. So if you had a regular hexagonal pyramid, the base would be a regular hexagon. This was supposed to be an equilateral triangle. So it's got a slant height of 30. I'm not very good at drawing anything, really. This should probably be dashed. And then we'll just do this. Okay, so this is my base, and then here's my vertex at top, and I know it looks terrible, but okay, it looks even worse on the screen. All right, so my base edge is 12, and then my slant height is 30. So slant height is the measurement from the vertex, so I'll just use this side here, goes from the center of the side and then up the exact middle of the side. Yeah, and that's 30. So you could maybe think of a net of it. So, and then, you know, if you had, your sides are going to be, you know, these triangles. Sorry, this is terrible. Kind of ignore that. Sorry, I'm sorry, this is just getting worse and worse. But this is your slant height, right? This is your base edge. So you could just draw it out like this to figure out the surface area. Remember, the surface area is the area of all four of these together, the base and then the three sides. And the slant height's going to hit the base at 90 degrees. So if you're using the net way to do it, then you would have 1/2 of 12 times 30. Okay, so that would be the area of this triangle here, right? Actually, all three of these, right? Because the base edge is 12 and the height's 30. So that's 180. And then times 3 would be 540. And then you have to find the area of your base. So it's an equilateral triangle. So some of you use Theorem's formula. So you have to find the semi-perimeter. So the base is 12 times 3 is 36. And then half of that is 18. That's your semi-perimeter. So then you take the square root of 18 times 18 minus 12 times 18 minus 12 times 18 minus 12. Okay, so that's one way to do it. Or you can use the Isosceles coincidence theorem, and you can drop the altitude of your equilateral triangle, which is isosceles, and it's going to split the base in half, and you know this is 12. And so what you get is a 30, 60, 90 right triangle. And you can use the Pythagorean theorem. So we just call this side B. So 6 squared plus B squared has to equal 12 squared. And you can solve for B, and that would be your height. And if you happen to know the 30, 60, 90 right triangle trick, then you would know that the height you're going to find is 6 times the square root of 3. But you can find that through the Pythagorean theorem too. So then the area of the triangle would be 1/2 times 12, because the base of the triangle is 12, and then times the height, which is 6 times the square root of 3. And so you end up with 36 times the square root of 3, which is, the square root of 3 is 1.7 approximately. So in my case, I'd be adding 62.35 whatever here, and end up with 602 something. Okay, so for most of you, you either thought the base was a square or you didn't know how to calculate the area of this triangle correctly. So that's the process there. All right, number 2. Box A has a length of L, a width of W, height of H. How could you manipulate the box's dimensions to make its volume 25 times greater? Explain your answer algebraically. So you've got your volume of your original box. So I'll just put volume original here. It's just L times W times H. Now, we want the volume to be 25 times greater. So we just have to manipulate our dimensions, multiply our dimensions by numbers that multiply together to get 25. So you could do something simple like 5L times 5W times H, which would give you 25 times LWH. Or you could just multiply one dimension by 25. Some of you tried to take 25 divided by 3, and you got 8 1/3. And you try to do 8 1/3 L, 8 1/3 W, 8 1/3 H. But you can't do that because 8 1/3 times 8 1/3 times 8 1/3 is not 25. So you'd have to take the cube root of 25 to do it that way. And that's 2.92. So you could do like 2.92. Actually, to be exact, you just do the cube root of 25L times the cube root of 25W times the cube root of 25H. And that's just kind of a pain. So it's simpler to do something like this. You could do 2.5 L times 10W times H, or whatever. As long as the numerals multiply to give you 25. That's what we're looking for. Okay. According to Cavalari's principle, if a cylinder has a volume of 151 and a height of 22, what would the area of a cross-section of a right triangular prism need to be for both figures to have the same volume? So for Cavalari's principle to work, they have to have the same height. So our prism has a height of 22. The cylinder has a height of 22. Both a cylinder and a prism, to find the volume, you take the area of the base times the height. So if I take 151 divided by 22, so the volume of the cylinder divided by its height, I get 6.86, which is the area of the base, of the cylinder's base. Okay, and so now for this prism, the prism is going to actually have the same area. You know, a prism thinking back to the notes here, this isn't a triangular prism, but the area of a cross section of this prism is the same as the area of the base. So this is the idea with Cavalier's principle. So we just we know that for our right triangular prism, the cross-sectional area is going to be 6.826, just like it was in the cylinder, for the prism to have the same volume of 151. Okay, this one next. Find the volume of the flower tray. So I'm just trying to adjust my document camera here. Find the volume of the flower tray in cubic inches. Cubic inches. Watch units carefully. Its end pieces are shaped like isosceles trapezoids and it's 1 foot deep. The bases of the trapezoid are P and N, which measure 19 and 10 in my case. So this is 19 and this is 10. And then it's 4.8 feet long. So, and it's 12, so this measurement here is 1 foot, which is 12 inches. It says it's 1 foot deep. So find the volume in cubic inches, round to the nearest hundredth. So to find the area of the base, right, area of the base times the height, find the area of the base, it's 1/2 10 plus 19, and then the height is 12. So this whole thing here, that's the area of the base. Then multiply it by the height of the prism, which is actually this 4.8 number, but we need that in inches. So 4.8 times 12 is 57.6 inches. All right, so area of the base times the height. Just plugging away at the O calculator here. So mine would be 10,022.4 cubic inches. Okay, next. All right, this is obviously just right off the practice quiz. Find the surface area of the cone made with the circle A if the wedge formed by angle BAC is cut out. The radius of the circle is 5. The measure of the arc is 120. So if this is 120 degrees, then the central angle is 120. This picture is not necessarily drawn to scale, round to the nearest hundredth. Okay, so if we, sorry, I'm just looking for my cone net, but I don't know where it went. Bummer. All right, so the idea there was like, if you take this piece here, I wish I knew where that went. Oh well, if you take this piece here and you connect B and C together, because this is all cut out, then when you connect B and C together, right, you end up with a lateral area of a cone. So this here is going to equal the lateral area of the cone. So how do we figure out what the area that is? So we take the area of the whole circle, which would be pi 5 squared, and then we multiply it by what fraction of a full circle we have. So in my case, I have a 120 degree wedge cut out. So 360 minus 120 is 240. So this is 2/3, right? 360, or sorry, 240 over 360 is 2/3. So I have 2/3 of my circle. So that means this area is going to be 2/3 the area of my circle. So I'm just doing the math here. on the calculator. So my lateral area is about 52.36. And then I need the area of the base. So the area of the base, if we look at looking at connecting B and C together to form my cone, the distance from B to C when they're connected is actually going to be the circumference of the base of the cone. So the circumference of the cone is equal to there's not a letter in here, let's just say this was D, is equal to the arc length of arc BDC. Okay, the circumference of the cone is the same as the major arc BDC, the length of that. Because when you put B and C together, that's how you form your cone. So we know how to define arc length. Define arc length, you take the degrees of your arc, which in this case is 240 over 360, and you multiply it by the circumference of your original circle, which is pi times 2 times the radius, which is 5. Okay, so 2/3 times 10 pi. So I'll just plunk that in here. It's going to give me 20.94 as the circumference of my cone. So the reason I need to find that is because I'm going to use that to find the radius of the base of the cone. So it's different from the radius of the original circle. So if I know the circumference of the cone is 20.94, and I know that the circumference of the cone is equal to pi times 2 times the radius of the cone, right? The formula to find the circumference of a cone or a circle is pi 2r. So I know the circumference already. I just don't know the radius. So I'm going to put this 20.94 in here and then solve for the radius of the cone. And so to do that, I just divide both sides by pi times 2, or 2 pi. Make sure if you do it this way that you put this in parentheses in your calculator, so otherwise order of operations will mess you up. Will mess up your answer. All right, so when I divide by 2 pi, I get 3 1/3. So the radius of the cone is 3 1/3. So I'm running off the page here. Okay, so then the only thing to do is define the area of the base of the cone. So area of cone base is pi 3 1/3 squared. And then I'm going to add that to my lateral area, which I found up here. So if I take 3 1/3 squared times pi, I get 34.91, and I add them together. And I'm going to make sure I'm going up in my calculator to grab the exact values. Oops. I don't know what happened here. So here's my area of the base, and I'm going to sorry, hold on a sec here. Okay, so here's my 34 point whatever. And then I'm going to add that to the 52 number. So I'm going to get an exact answer, or well, I'm not going to round to the very end. That's what I'm trying to say. So rounding to the nearest hundredth, 87.27. All right. Okay, moving on. All right, you and your siblings love ice cream. Who doesn't? You're at your favorite ice cream place. You have a discussion about waffle cones. Which waffle cone takes more waffle to make? Assuming no overlap, the cone has a slant height of 7 or in a radius of 1 inch, or the cone that has a slant height of 5 and a radius of 1.5. So obviously not drawn to scale on my picture here because I made whatever. Anyway, the key here that some of you botched when you were showing your work is that you put a base on this cone. Waffle cones don't have bases, otherwise you wouldn't be able to put the ice cream in. So we just need to find lateral area. So the lateral area of a cone is 1/2 slant height times the perimeter of the base. So 0.5 times 7 times pi times 2 times the radius, right? Because the perimeter of the base of a cone is pi times 2 times the radius. So 21.99. And then for the second cone, 0.5 times 5 times pi times 1.5 times 2, 23.56. So this one uses more waffle. This is 1 inch square. All right, number 7. A tunnel has to be lined with ceramic tiles that are 6 square meters for each tile. The tunnel, as shown, is 1/2 of a cylinder with the length. So the length is 3,046 meters, and the diameter is 21 meters. The question is, how many tiles do you need? Round to the nearest tile. So again, here we're not putting bases on our tunnel. Then you can't tile the openings to the tunnel. So again, we're looking at lateral area of a cylinder, which is equal to perimeter times height. And since we only have 1/2 a cylinder, right? 1/2 of a cylinder, we just need 1/2 of the perimeter times the height. So the perimeter of the base here is just the diameter times pi. So 21 pi. And then the height is 3,046 meters. So 0.5 times 21 times pi times 3046. So that's going to give me a number, 100,477.56 square meters. So that's how much area I got to cover. Every one of my tiles covers 6 square meters. So I'm going to divide this by 6, and that gives me 16,747 tiles. All right, moving along. Find the surface area of a box with a height 27, length 28, width of 16. Okay, a couple ways you can do this. One, you can use the formula perimeter times height plus 2 times the area of the base. So the base is going to be your length and your times your width, right? So the area of the base is equal to 28 times 16, which is 448. And then the perimeter of the base, so is 2 times the length plus 2 times the width. So that would be 56 plus 32 is 88. and then the height is 27. So this is one way to do it. So perimeter 88 times the height 27 plus 2 times the base, which is 448, gives me 3,272 for the surface area. So you also could do the 2 length width plus 2 length height plus 2 width height formula, and that would give you the same result. Just a couple more here. Find the volume of a cylinder. Hold on. Adjusting. Okay. Find the volume of a cylinder with a height of 6 and a base radius of 8, round to the nearest hundredth. So the volume of a cylinder is pi r squared h. And so you got a height of 6 and a base radius of 8. So pi times 64, that's 8 squared, times 6. And you get 1206.37. All right, and then the extra credit. Cube G has a side length of 11. And you got cube Y has a surface area that's 29% bigger than cube G. This is extra credit, by the way. So I can figure out the surface area here by doing the formula 6s squared. So 6 times 121, that's 11 squared, is 726. And then to find this surface area that's 29% bigger, I take 726 and I multiply it by 1.29, which is the same thing as if I did 726 times 0.29 and then add it to 726. This is just doing that all in one step. Both ways work. So if I multiply that by 1.29, that gives me 936.54 as the surface area of cube Y. Okay, but the question is, what is the volume of cube Y? So the volume formula is s cubed. So I got to figure out the length of a side here, working backwards from the surface area. So the surface area formula is 6s squared. So I call this one s. I'll just call this, use a side of, say that the side length is y here. So then the volume would be y cubed. That's just because this is s and don't want to be confusing more than I already am. So 6y squared is the surface area. We know that's equal to 36.54. So I'm going to solve and divide both sides by 6 and get 156.09. And then, so y squared is 156.09. I got to take the square root of both sides. And that gives me y is equal to 12.49. Sorry, I'm off my page here. Okay, so I divided both sides by 6 and take the square root of both sides. Y is 12.49. Which, going back to my original, I'm only 29% bigger. So my original side is 11, right? My bigger cube has a side of 12.49. That sounds reasonable. Now to find the volume, I just got to cube this. So volume equals 12.49 cubed. It's, yeah. So again, when on my calculator, right, I find it's 12.49 blah, blah, blah stuff. I don't just take 12.49. I just take that answer and cube it. So my answer is exact as it can be. So I get the volume is 1950.13. So I'm only rounding at the very end. This is cubic centimeter. As some of you found on the quiz, like you did some rounding early in the problem, and because you rounded multiple times before you found your final answer, when you finally got your final answer, you were significantly off. Like I know some people did it with the tile question where you were off by like 50 tiles because you did some rounding in here. Anyway, so that's the going over the quiz. If you have any questions or you want me to go over your specific question on your quiz with your numbers, shoot me an email. I'll be happy to do that for you. And hopefully that helps.